Hello, and welcome to the director's cut of building this desk. It is one of the longest and most detailed desk builds YouTube has to offer. If you would instead like the 8-minute version of the build, click in the corner. Today we're building my ultimate all-in-one workstation. I'm a general artist and I have a lot of random tools that need to be stashed in one place or another. Built-in charging and a USB hub are a must for many of these devices. 5.1 surround sound keeps me going while working up to 16 hours a day. It can also function as a recording studio. More on that later. Under my editing rig, I included a shelf for a VR headset. The desk has adjustable height legs for sitting, standing, and anything in between. Maintenance mode is quite nice. And with this volume of hardware, there is maintenance. 3D printed cable routing guides 20 plus cables through the desk, culminating in just 2 wires that power the whole setup via a 2200 watt battery backup. I am not a woodworker by trade, and over the years I have taught myself most everything I know. As a result, you will see designs, materials, and processes used on this channel in ways that you may have never seen before. If you enjoyed today's episode, be sure to like and subscribe. Custom 3D printed parts not only play a functional role in the finished desk, they also proved very useful during the build itself. Many of these parts are available for download along with the plans for the desk. You can find the links in the description. So let's get on with it. The wood for the top side came from an old school bookshelf. There was some damage to it. And let me tell you, somebody at this school was a real... And what do we do with dirty boards? Well, we send them through the planer where they belong. All joking aside, there was some really nice wood under there with a range of colors from probably 20 different trees. There was not quite enough wood from the bookshelf to cover the whole tabletop, so I picked up another piece of hard maple and trimmed it down to match the bookshelf pieces. The new board that is flat sawn has a bit of a different look than the reclaimed pieces, but they blended in well enough. The bookshelf boards were also trimmed and cut to a smaller size. My planer has a bit of flex in it that translates into varying board thickness. The melamine clamped in there helps some, but the boards still come out plus or minus 0.03 of an inch. This results in a lot of sanding down the line in a tabletop that is not perfectly flat. I don't have a jointer, so I made one using a few washers to create a small offset on one side of my router fence to support the board after it has been jointed. It works pretty well. If you want to see how I made this router table and fence, check out the link in the upper right hand corner. Up to this point, we have prepped the wood for the top side. The rest of the construction is 1/4 inch, 1/2 inch, and 3/4 inch Baltic birch plywood of various grades. Once all the pieces are cut, we can start doing some secondary machining processes. Then we will glue things up and give it some paint. In the design phase, I had originally planned for 2 drawers, but after calculating the weight of the tabletop and the extra hardware and electronics, I realized that I would need to cut a few things out. The new version of these legs support 360 pounds, making all of this a non-issue. Check the description for links to all the parts in this build. Using my circular saw, I cut the panels into smaller sections. The table saw then splits the longer strips into individual parts. Next up was cutting the holes for cable management. I wanted them to be rectangular with rounded corners. What I came up with was a 2-part router guide that could make 4 different sizes of holes with 2 different radii. The stencil can be clamped in place or screwed in or both. One of my main concerns with this approach was the potential buildup of dust in between the 2 components. This proved to be a real issue, and I had to clean out the space in between them frequently until the shape was complete. It works, but I would consider it a flawed design that needs more attention before I offer it as a download. The other issue was the amount of friction in between the 2 printed parts. To help them slide more easily, I applied my favorite shop lubricant, Johnson's Base Wax. Just a small amount made a huge difference in performance. All of the holes designed for cable routing got a 1/4-inch radius. The holes for the charging dock and USB hub were cut with a 1/4-inch bit. The spacing for these was built into the template. Over the years, I have found USB hubs to be occasionally unreliable with some devices. So I decided to run 2 USB 3.0 cables directly into the back of my computer from the tabletop. I could also set the spacing on the USB ports to be wider than the usual off-the-shelf unit. For the next few operations, I used a router circle guide to create the rounded corners on the bottom side of the desk. The next tool I designed was an attachment for my router that interfaces with my circular saw track. This allows me to cut nice straight channels into the workpiece. Off of the printer, it didn't slide at all, but before throwing it in the garbage, I did a little sanding and applied some paste wax. After that, it worked amazingly well. It was definitely the best performing 3D printed tool on this project. I would offer a download for this, but my circular saw track is pretty obscure and the guide is not a universal fit. If anyone really wants one, let me know in the comments. This tool not only worked great for trimming, but it also produced nice shallow dados and grooves on the top and bottom side of the desk. The last thing that I used the guide for was making a pen groove for the drawing tray. For the final 3D printed router attachment, I made an edge guide. Installation was the same for all the router attachments. I made one version of this that cuts a 1/2-inch wide channel and another that cuts 3/4 inches wide. This tool was not quite as easy to use as the last one. It often cut the corners too deeply because the router gets unstable there. That's what I'm talking about. To fix the issue, I clamped an outfeed board next to the workpiece and the problem went away. The friction on this print along the wood surface was also significant. I didn't want to use wax on this because I didn't want to transfer the wax onto the wood. Using the router table, I cut some rabbets into parts of the drawer as well as a few grooves for the bottom of the box. Various components also received additional operations on the router table. Once that was wrapped up, it was on to the glue-up of my lifetime. It all started with the drawer. I used a band clamp to hold everything in place while it dried. The drawing tray needed a secondary board glued onto it in order to make it a bit more rigid. This also adds some thickness for the mounting screws. The 1/2-inch plywood I used for the top of the desk was not strong enough to support the expansive front edge. To compensate, a piece of 3/4-inch plywood was added here. You may have noticed that I'm doing the main glue up on top of the desk legs. I don't have a table large enough for this operation, and the legs actually make a great work surface. There was one spot where I misread my drawing. This patched up easily with a small piece of plywood. I have a total of 7 clamps for this sort of thing. As a result, much of my glue-up was taken in stages. After the 2 end boards were glued up, I moved on to the back and center supports. I have a standard Imperial set of router bits, and the plywood I used is undersized. This results in some pretty significant gaps in my construction. To force more of a connection between the parts, I used some veneer sheets to fill in those gaps. This time I did more of a thorough job of taping the glue joints so that I didn't get too much glue on the wood surface. For the whole build, I used 2 bar clamps, 2 36-inch clamps, and 3 13-inch clamps. Before I glued up the bottom side, I needed to pre-drill each and every hole for the tray table and the various cable routing guides. Once the bottom is glued on, it's going to be very difficult, if not impossible, to get a drill into all of these tight spaces. The drawer hardware also gets its holes pre-drilled. After marking up everything, I realized that I was going to need one more tool. The holes all need to be drilled 3/8 of an inch deep. This is what I came up with for a depth stop. It fits a small diameter bit for making small screw holes. The end has a cavity for accepting loose chips that are pulled from the hole. This allows the stop to make good contact with the drill surface for nice, smooth bottoming. One more piece to go. Slight offsets on the vertical boards caused the bottom of the desk to be a bit too long in this one direction, but that was easy to trim down. For the biggest glue up of them all, I realized that these two surfaces needed to be brought together as smoothly and as quickly as possible. That's when I got an idea. With 2 ratchet straps and 4 big lag screws, I suspended the top of the desk from the ceiling. This allowed me to easily access all parts of the table for the upcoming steps. I almost forgot to drill the holes for the desk control unit, so I took care of that despite some wobble. The test fitting went smoothly. This shot also gives me a chance to show off the sizable gap in this corner. I don't actually have enough clamps to effectively join the remaining pieces, so I decided to screw the legs onto the table during the glue up as a way of holding it all together. The top of the legs needs to be flush with the bottom of the desk in order to have the screws pull the boards together rather than pulling them apart. I used a few thin sheets of plastic on either side of the table to make everything flush. Everything was brought into alignment and the holes for mounting screws were pre-drilled. Working as quickly as possible, I laid down the glue and raised the legs until the parts slotted into one another. Then, moving around the desk, I clamped each section together, ran the screws into it, pulled the clamps off, and repeated the process in the next area until everything was secure. Then I removed the excess glue, pulled the tape off, and wiped the joints clean with a damp rag. My joinery was a bit off in places, so I had some sanding to do. The top edge got chamfered at 45 degrees. This will create a parting line between the veneer on top and the stained plywood. I made this shirt a while back. It's a joke about the asteroid that killed off the non-avian dinosaurs. If you find it amusing, you can buy it at the link in the description. All of the maple planks had a range of tones from pink to white to yellow. I tried to mix them into as much of a smooth gradient as possible from one end to the other. Then I glued up as many as I could at a time. First, taping off the areas I wanted to keep clean, evenly spreading glue over the joining surfaces, and laying down the next few boards. I allowed these glue-ups to dry for 5 hours each. A fan helped make sure things dried enough before moving to the next set. After drying the whole thing for at least 24 hours, I sanded the top flat and trimmed off the excess with a flush trim bit. The The same bit was also used to bring the holes in the plywood through the maple planks. Most of these went smoothly. The 2 holes that are designed for running cables were rounded over to 1/4 inch. One more piece to go. I used my circle guide to cut the round edges of the handle into the drawer face, then moved on to the bandsaw. I left an extra inch of material on the top side of the face. This prevented me from over-rounding the top corners of the handle while sanding. Once that was done, the extra material was trimmed away. After sanding this piece, the last step was raising the grain. I will be using a water-based stain and top coat. Because the stain is a solid color, I really don't want to have to sand the wood after it has been stained. It's easy to sand right through the stain itself. The left side of this board has been painted with a thin coat of water. You can see how the grain has popped out from the surface. Once dry, the boards are lightly sanded to remove the roughness from the surface, and then they are ready for coating. I applied the top coat to a few select items to begin with. I prefer to do a first coat with a bristle brush, and then follow-up coats with a sponge brush once the surface is smooth. The most important item to coat first was the maple planks on the top side of the desk. Because I want to stain the lower portion of the desk black, I felt that the top side needed protection from the stain. If a single drop of what is essentially black ink were to land on the unfinished top side, it would be nearly impossible to remove. After sanding with 320 grit sandpaper, I did a second coat. I would have used a sponge brush for this, but I didn't have any at the time. Then it was time for the stain. I taped up the top side so that I could run the brush right up to the edge. This is my first time staining with a solid color like this. There was something satisfying about it. The tape was mostly effective, but there was some seepage. Thankfully, with the top coat already on, the stain removed with a small amount of sanding. This stain was intensely dark, and I ended up having to use a flashlight to make sure I was getting complete coverage. The top coat went on after the stain dried for 24 hours. Some stained particulate, probably sawdust, ended up on my brush and in the paint tray. For this reason, the stained parts received their first coat separately from the lightly colored maple pieces. I finished the desk in this way so that all the wooden pieces would have a matching sheen. That said, for this application, black paint would have worked well and been less labor-intensive than this method. I sanded with a sponge brush and then moved to an even lighter method so that I didn't remove too much material. The boards were cleaned with a dry cloth and then wiped down with a wet towel. This highlighted any areas where I might have gone through the stain. I used an ear cleaner for touch-up. Most parts got just 2 top coats. The parts that received frequent contact, like the top and front side of the desk as well as the drawer face, all got 3 coats. The parts that received frequent contact, like the top and front side of the desk as well as the drawer face, all got 3 coats. The recommended minimum for this brand of urethane. 2 coats seemed to look nice enough without really starting to highlight the various blemishes in the low-grade plywood. 3 coats gave a reasonably smooth surface. A 4th, I think, would have gotten too glossy for my taste. The main desk got the same treatment as the peripheral items. Finishing the interior and bottom was much easier with the desk pointed upwards. Once dry, I could flip it over and coat the back and top sides. I realized about halfway through this project that my dependable but old camera was not going to be able to get a decent video of the desk after it was done, so I finally made the jump to 4K. I'm not sure about you, but I feel that this shot was the first time that I could really see the grain of the wood stand out like it does in person. Once the parts dried, they were quite slippery. This is, of course, not an ideal feature for a monitor stand, so some rubber feet took care of that issue. Another issue easily solved is PETG strings on my printed parts. I designed two types of cable management clips, one for specific size cables and another that will hold any size wire with a light grip. Thanks to the pre-drilled holes, these went in easily despite some pretty awkward angles. Now that we have cable management, we will need some cables. The AC and USB power supply dropped in nicely, and so did the USB hub. To make this, I bought two cables and used their profiles to create a cutout in the main housing. The ends of the cable slide snugly into place with two spacers to create the perfect fit. If you want to print one, the link for the parts and the specific cables used are in the description. A rear access cable management solution was just not an option with such a large desk. I went with black for the lower part of the desk so that all of the cables would blend in nicely. This desk control unit went on well enough, but the small screws and the tight angle were not a pleasure to work with. Now, before I loaded things up with gear, I couldn't resist doing one weight test. Moving on, we have to install the drawing tray. It was originally a keyboard tray. I got it a few years ago, but quickly decided that I preferred my mouse and keyboard on the more solid desktop surface. It's a good piece of equipment though, and I'm happy to have found an alternate use for it. The table went on with just enough space for access to the adjustment knob. The tray is not extremely solid, but it's good enough for sketching. Jumping ahead for a moment, this is how the desk hardware installed between the legs. One last design was printed to help secure the knee bar. This piece obscures the rather unsightly galvanized steel bar under here, and it also adds a small cushion to the thing that I will inevitably smash my knees into. The only thing left to do is install the drawer. There was some top coat in the holes that I removed using a drill bit. The depth stop actually made a great finger drill for this process. With the help of a plastic sheet, I determined the ideal location of the drawer and drawer face. All the necessary measurements were taken, and then the slides could be installed. I used 28-inch full extension slides for this project. That all worked well. So then the drawer got two holes drilled into it for mounting the drawer face. The holes were a slightly larger diameter than the screws that would eventually run through it. This will allow the screw to pass through the drawer and only pull on the drawer face itself. The front of the drawer was then taped in place for the next operation. Using an undersized bit, the holes were marked, then drilled to the proper depth. For this pivotal moment, I was thinking, how can I really nail this shot? And the answer was clear. Make everything slightly out of focus. This is such a welcomed upgrade over my old desk in both form and function. I tend to prefer dark wood tones, and I was concerned that I might not like this tabletop. But in the end, I couldn't be more satisfied. I've had this tablet for years, but couldn't fit it on my desk with all the stuff on there. Not only is there a place to put it now, but I can get the full drafting table experience as well. What was once the mess of cables at the back of my PC is now less of a mess. In the end, the desk isn't all that great of a recording studio. It gives vocals a hollow sound that I don't care for, but that same resonance makes the 5.1 system sound really good. There is a significant bend in my monitor stand. I didn't need quite so much clearance in the back, and I should have made the vertical supports quite a bit thicker. This has been updated in the drawings available for free at the3dhandyman.com. Oddly enough, the bow in the wood caused the rubber feet to shoot out from under the stand after just one day. Thankfully, this only happened on the front side, and the feet in the rear have held in place. I didn't bother to spend a lot of time filling gaps and hiding the end grain of the plywood. All of these imperfections are really only visible under the extremely bright lighting that you see here. One thing that I like about this configuration is that it gives me a place to put the cable for the VR headset. I have been making VR experiences for about half a decade now, and in the near future, I plan to show off some of this content and a whole lot more. This channel is still quite new, and it would be very helpful if you could post in the comments what you like about the video and if there's anything that I can do to improve my content. As always, thanks for watching, and remember to like and subscribe for more videos like this.